Hi. Exam 3 review. So let's take a look. Exam 3 is on chapter 4, and then we subtract 4.8, which is the Newton's method, because it's really annoying to calculate without ability to program the stuff, right? So chapter 4 minus 4.8, but I'm going to add 3.11 to it, which is related rates, because you did so well last time on related rates that it begs to be repeated on this exam plus the final. So chapter 4, take away 4.8, add 3.11, and you have a 9-section test.
That's one thing. In 3.11, I was watching the video and it freezes. And because I
You just watch the older ones.
the other one? Okay.
Yeah, older ones from the, because if you go to a YouTube channel and you type in related rates in a search, right, when you are on the channel, you type in inside the search, it will come up with 6, 7, 8 related rates. One of them will work. It just depends on the network. All right. Now, standard stuff for the test, no graphing, calculators as usual. Bathroom before, right? Bring in some kind of liquid or chocolate to get your sugar going. And we are looking at 10 problems, 100 points, 16%, right? So highest stakes so far. So we have 10 problems, 100 points, 16% of the grade. And I really hope that you guys are going to go home tonight, latest tomorrow morning, and do that chapter 4 post-test to find which skills you are lacking so you can fix those particular skills till next Tuesday. You also have your quizzes going and all of that stuff. Remember, the quiz on quiz 1 will reopen on Saturday and Sunday, so you can solve any of the 2 days, right? All right, cool. What do we have for our topics? Number 1, min-max problem. This is not the applied one. This is just the section 1 where you just find min and max. Now, min and max we have also on the closed intervals. So you have a min max on AB or AB, and those are different, right? Because for the second one you have to calculate the endpoints as well. Number 2, first derivative test. Number 3, second derivative test. Number 4, graphing functions, and that's graphing functions by hand. Now for this one, guys, for graphing functions, I will provide all of the specs. You just need to graph. Remember those graphing problems for 40 minutes because you had to find x and y intercept and the domain and the asymptotes and first and second derivative, right? All of that will be given. You just need to draw the graph looking at the information. You are going to have a separate problem to show off your math skills for the first derivative test. It will have nothing to do with graphing question, right? Separate problem, different function for the second derivative test. Do the inflection points and just concave up, concave down intervals, right? And there will be no graphing on those. And then I will give you separate problem. I'll give you all the specs for graph, and then you will just draw a graph, okay? I mean, I can make this into a three question exam, right? Give you a 40 minutes graphing question, give you a min-max optimization word problem, and a L'Hopital rule for and we're good to go. Let's call it exam, right? Number 5, we have the mean value theorem, which is where you find C. You know what that means when you look at it. Number 6, we have linearization. I will put in parentheses tangent line. I can't care less whether you are memorizing the LX formula or you're just going to do the tangent line. It's the same thing. Number 7, differentials. So linearization approximates the value, differential approximates the change. So that's what we have. Number 8, L'Hopital rule. L'Hopital's rule. Probably A and B, like 2-part, or maybe even 3-part. I don't know, 2 or 3, like A, B, C. One of them will be just the basic of the basic for L'Hopital. It's already 0 over 0 or infinity over infinity. You just take the derivative and write the answer, right? So one of those will be. Now, one of them must be 0 times infinity because those pop up frequently in Calc 2. So you are guaranteed to have the basic. You are guaranteed to have 0 times infinity. Those two are guaranteed. Now, for the third one, if there is a third one, it's either going to be infinity minus infinity or one of the exponential, most likely one of the exponential ones where you hit the ln and shovel the things around. Number 9, antiderivatives, also known as integrals. Oh, I am going to put plus C in blood over here. So it's either going to be plus C or minus 1 on the test. 10, 3.11 related rates. Oh, wait, where are my word problems for optimization? Holy nightmare. 11.
No.
Optimization word problems. If you remember optimization, we did a farmer, right? Whole bunch of stuff, and then maximum volume, minimum surface area, and all of that cool stuff. We also had that problem where we figured out for that oil company which way they should run the pipes to save, right? To save $350,000, and then they give you 10%. Right? But I mean, if you do that 10 times a year, 10 times 15 minutes is 150 minutes. It's like 2.5 hours of work for 300K. Yeah, life is good with no calc, right? All right, cool. Related rates is like a filler. If we need to add anything else, it's going to be a word problem from related rates. Most important sections, right? Section 10 and 11 for your employment, right, within engineering and stuff like that, because those are the word problems, right? The situations that you can actually run into while working. So I already explained the first part. The mean value theorem finds C. Something similar like what we just had for integrals. You'll remember that. Linearization talk. Differentials. Okay, differentials have that formula dy equals f prime of x times delta x. Right, that was differentials. And delta x was x2 minus x1, old, new minus old. Right, that was that. I already talked about L'Hopital rule. Antiderivative integrals also probably two-part, something that is basic and something that would use the rule to kind of maybe split or something. But nothing outside of the example that you guys already seen. You are only integrating polynomials, basic e to the x, 1 over x goes into ln x. Trig functions like sine, cosine, secant squared, which is integral of secant squared is tangent. So just the basics. We are not using any, hard stuff. Hard stuff is in Calc 2, chapter 8. Wait. Cool. Chill. Right. We'll do trigonometric substitution there. I know. That's the spirit. Do you have any questions, any problems? Did you run into any homework issues? Yes?
I wish I could do that by back. My L3 is full. What? My L3 is full. L3? My L5 is
You can just scream the function. All right. We are going to do the first derivative test on a function that has trig and so find the intervals of increase, decrease using first derivative test for the function f of x equals negative 2 cosine x minus 2x. Like this?
No. Minus
Like this? On interval 0 to 2 pi. Is this cool?
Yeah, I think x is outside.
This x?
Yeah.
Then that will make it. Oh, okay. X is outside. Okay, fine. You win. Like this? So minus 2 cosine x. Okay. For the first derivative test, we need to take first derivative, set equal to 0 to find critical points, which would be partitioning our domain 0 to 2 pi. We do not have any vertical asymptotes, so we don't have to worry about those. Cosine has no vertical asymptotes. Linear function x has no vertical asymptotes. So no VAs, we don't have to worry about that. If there were any vertical asymptotes, we would have to include those values in our partition as well. So, f prime of x is equal to, derivative of cosine is negative sine. So that's going to kill the negative in front. And minus, we're just going to have a root 2 over there. Now we set this equal to 0 and we solve the equation. Equation is sine x equals root 2 over 2. Now, when is sine positive? All students take calculus first and second quadrant. All students take calculus. There we go. So sine is positive at pi over 4 and 3 pi over 4. So my x is equal pi over 4 and 3 pi over 4. And both of those values are between 0 and 2 pi. We get to keep them both. So now I'm going to draw the partition. We have 0, pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5, 6, 7, 8. Because 8 pi over 4 is 2 pi. and this is my 0. I have a partition at pi over 4, and I have a partition at 3 pi over 4. So this is the partition that we do. And now we pick test values inside these partitions. So what are the good test values? Well, we have the easy ones. The easy test value here would be a pi, because that is in that pi over 2, which is obvious, because that's midway between pi over 4 and 3 pi over 4. Pi over 2 is actually 2 pi over 4, right? So we have 1 pi over 4, 2 pi over 4, 3 pi over 4. 2 pi over 4 cancels down to pi over 2. And what is the value that I can use in the left? Pi over 6. Pi over 8, we don't know what the value is, right? So we're going to use pi over 6 here, because we can calculate sine and cosine of pi over 6 without a calculator. All right, so now I have my f prime of pi over 6. F prime is 2 sine pi over 6 minus root 2. Sine of pi over 6 is 1/2, so I have 2 times 1/2 minus root 2. This is equal to 1 minus root 2, and that's less than 0. I don't care how much it is. I know that root 2 is 1.4, about, so this is going to be negative. Boom. Decrease on the first interval. F prime of that was not a sneeze. It sounded like someone took the Band-Aid off. 2 sine pi over 2 minus root 2. What's sine pi over 2? Very good. So this is 2 minus root 2. That's more than 0. Boom. Increase. F prime at pi is 2 sine pi minus root 2. Sine of pi is minus 1. So I have 2 times negative 1 minus root 2. This is 2 negative numbers. So definitely less than 0. And we have a decrease. So now, answer. F of x is decreasing on 0 to pi over 4, union 3 pi over 4 to 2 pi, f of x is increasing on pi over 4 and 3 pi over 4. Using correct parentheses is important. Your interval was the closed interval, 0 to 2 pi, which is why you have the brackets with 0 and 2 pi. Now, inside you are using parentheses because you cannot claim increase and decrease on pi over 4, because pi over 4 is a single point. You don't measure increase or decrease at a single point. You have to have some range interval, right, to compare at least 2 points. So pi over 4, right, doesn't belong to any of the intervals. Cool? Cool. That's calculus. Any other questions? Abby? You have another one? Cool. Anyone else? I can't remember that. Second derivative test now on a 4th degree polynomial. Find intervals of concave up, concave down for f of x equals, was it a 2x to the fourth minus 4x cubed plus 4. Good. We are on infinite domain. No vase, because it's a polynomial. So our partition will not include any vertical asymptotes again. We need the second derivative, but to get there we have to get the first one first. So 8x cubed minus 12x squared, 4 dies. And then the second derivative is 24x squared minus 24x. This is the one that we set equal to 0 to find inflection points. I am going to factor 24x and have x minus 1. So x equals 0 and x equals 1 are two inflection points for which I can find y value if need be for graphing problem. We don't need to find, in this case, we only care about x values now. Partitioning for this problem is done between negative infinity and positive infinity, making stops at 0 and 1. We are supposed to pick 3 test points, and we'll pick negative 1, 1/2, and 2. We're going to run second derivative test using the second derivative, and the second derivative is 24 times negative 1 squared. Oops, supposed to say f double prime of negative 1. There we go. So 24 negative 1 squared minus 24 times negative 1. This is 24 plus 24 larger than 0. I'm not going to waste energy to add it into 48. I'm not. I don't care what the value is. I just need to know if it's positive or negative. If I'm adding any two positive numbers, value is positive. I don't care whether the value is 7 or 48. So I'm not going to bother, just bigger than. And that means that we have a concave up, right, on the first over here. We have a concave up. Now we have to do the same for 1/2. And that's going to be 24 times 1/2 squared minus 24 times 1/2. 24 times 1/2 squared. 1/2 squared is 4. 24 divided by 4 is 6. Minus 12. This is a number minus larger number. So that's going to be negative. Concave down. The last value we are computing is value at 2. That's 24, 2 squared, minus 24 times 2, which is bigger minus smaller, so larger than 0. Right? Do we see that the first number is twice as big as the second number? Good. Concave up. Answer: f of x is concave up on negative infinity to 0, union 1 to infinity. F of x is concave down on 0 to 1. And that's the answer. We are looking for intervals of concavity for second derivative. Your values have to be 2x values, because I've seen all kinds of creative answers. No, I just need x1, x2, and that's it. x1, x2. And on that interval, the function is either decreasing or it's concave down or something is happening. But you need 2x values. Good.
Question.
Yes.
You said for the graphing functions, you give us certain specific things. Is this something we would be needing to solve for to do the graph, or what was the things that you said we need to solve for?
Well, what you just seen are exact questions for the test with different functions. So you will have to be able to do 100% of what I did in these two examples just with a different function, because you have a standalone problem for each one of these.
And then we would graph that?
No graphing. This is it, right?
That's
That's it. Now for graphing question, I will give you this here. I'm not going to give you any of this. I'm not giving you even the function. So let's say you want to cheat with a cell phone app or the graphing calculator under the desk, right? To see, use Desmos to cheat on the graphing question. You can't, because function will not be mentioned. I'll just say you have a maximum at f of 0 equals 3. What does that mean? Maximum at f of x, f of 0 equals 3. F of 0 equals 3 means your x value is 0, your y value is 3, so the point where the maximum is 0, 3, which is on the y-axis. And because it's a maximum, you draw a little frown. Then there will be other stuff given, vertical asymptote or something, and then you just snake your function through, right, all of the points that are given and follow bend around asymptotes. Right, so standard stuff. Everything is given: x-intercept, y-intercept, vertical asymptote, mean, max, interval of increase, intervals of decrease, intervals of concavity. Everything given to you. You just need to transfer all the points from the chart that I give onto a graph. Minimum gets a smiley, frown gets maximum gets a frown. You have the vertical asymptotes, horizontal asymptote, slant asymptote, maybe, right? Things next week, so plenty of time to work it out. First derivative less than 0 between blah and blah values. Oh, okay, it's decreasing function there, right? So you'll show off your maths graphing skills, right, with something that will be given to everyone the same, and then these are separate problems. Well, anything else? Yes. I guess you're designated.
Fuego or caliente? What is Fuego and caliente. What's the difference? One's like hot.
Fuego is fire. Caliente is hot.
Oh, okay, that's cool.
I know what you mean.
You know what I mean? Wait, what's the gap? Ask Nicola, what's the gap? Yeah, what's the worst thing?
Saying so much like offending?
Yes, it's like the worst thing, the absolute worst.
Yeah.
All right, here's the cool differential question where we have a right circular cylinder that is going to decrease its height but maintain the radius. Now, when the height in a cylinder goes down, then the volume goes down as well. Application: you're sipping the Coke, right, with a straw, and when you take a sip, the height, right? You can't change, you don't change the width of the can. It's always the same radius, right? But the amount of liquid, when you take a sip, right, with a straw, it goes down a little bit. So this is just a geometry question. Now I gave you this, but then you can think about pistons, that will, right, in the engines and so on. So there's a lot of stuff that you can work out with this. Now, you have a cylinder, a right cylinder, and for this cylinder, radius is fixed at 19, and the height of the cylinder will decrease from 15 down to 14.9. Now, it's very important here to understand that this radius is fixed, constant, and because it's fixed, it is not a variable. Therefore, when you do your derivative, you are not going to be differentiating r because it's constant. Therefore, there will be no product rule. What's the volume of the cylinder? It's area of the base, which is pi r squared, times the height, which is h. Now, it's important, again, I'll put it in blood over here, that's constant. So, when I take the change in volume in respect to h, dv dh, it's going to be pi r squared, because derivative of h is just 1. There is no dh, dt and stuff, it's not related rates. Now, we are going to move dh to the other side and get the differential, which is pi r squared dh. We know that dh is the same as delta h, and delta h is h2 minus h1. That's new minus old. New is 14.9 minus old is 15. So delta h is negative 0.1. So I have the change in volume is approximated by dV, and dV is pi 19 squared times negative 0.1. So dV is equal to, and now you use your abacus, it's going to be a negative, obviously, because you are losing volume, right? Because the height decreased and the size of the can is the same. If you are to change radius and you change radius and you change the height and the volume will be changing, welcome to Calc 3. Yeah. You have 3 variables minimum, right? So I have 19 squared times pi times negative 0.1 for a total of negative 113.4. Units cubed, whether it's inches, millimeters, or whatever.
Slang.
19 squared times pi divided by 10. Let's say it's good. Anything else?
Gotta go along for the ride. Make it to the destination.
No more? All right. See you next week.